For your classwork, you can feel free to use graphing paper to actually graph the points on your graphing paper so you can actually see it. However, I'm not going to do that. I'm just going to do it using the facts. So we've been given 3 points and we know that it's a triangle, but we want to classify it as specifically as possible. So the first thing that I want to do, which is what you should do for any triangle, is to find the length of each side. So recall we're using the distance formula, which y2 minus y1 squared, y2 minus y1 squared. Okay, so this is what we're using. So I'm going to do the length of DE. So that is equal to, I'm going to go ahead and set it up just like I showed you in the previous video. Okay, so I'm going to use this as my 1 and these as my 2's. So for my x's, that's a 0. And this one is also a 0. For my y's, I have -1. And that one's a 1. So I'm going to go ahead and simplify. That gives me 0, because 0 squared is just 0, plus -2 squared. Okay? So that ends up giving me the square root of 4, because -2 squared is 4, and the square root of 4 is actually 2. So, and you don't have to simplify when you're finding the lengths because we just want to see if they're the same, but I just chose to do that. So we got 1 down, 2 to go. So the next one, I'm going to make F my 1 now this time. So for EF, go ahead and set it up. My 2, so my x2 is 0. My x1 is a square root of 3. My y2 is -1. My y1 is 0. So when I simplify that, I get negative square root of 3 squared plus -1 squared. Please make sure that you're careful when you are simplifying. So when I do that, that gives me 3 plus 1. If I square a square root, then it just cancels out the square root. So that ends up giving me the square root of 4 again, which is 2. Okay, so far 2 of the sides are the same. Now let's do the last one, which is DF. So I'll make this my 1 and I'll make D my 2 this time. And I'm going to go ahead and set up. So for DF, my x2 is 0. My x1 is square root of 3. My y2 is 1. My y1 is 0. When I simplify that, you should be able to simplify stuff on your own by now. When I simplify that, I'm going to get the square root of 4, which is also equal to 2. So, as I look at my lengths, all of them are the same. Each length of the triangle is 2, which means that this is an equilateral. So I'm going to write that right here. Because it is an equilateral, I don't have to check the slopes to see if it's a right triangle. Reason being is because all right triangles have a 90-degree angle and equilaterals can't have a 90-degree angle. Okay, so for the rest of these problems, that's what you're going to be doing. You need to find the lengths. If it's not an equilateral, you also need to find the slopes to make sure that it's not perpendicular. Okay, so let's try number 2. First thing I'm going to do is I'm going to find the length of each side. So for AB, this is going to be my 1 and my 2, so I don't get lost. Okay, so x2 is 5, x1 is 2, y2 is 1, y1 is -1. Got a double negative there. I had the subtraction sign, but I'm subtracting a negative, so I'm going to go ahead and turn that into a plus now because I had the double negative. Okay, so now this becomes the square root of 3 squared, positive 3 squared, excuse me, plus 2 squared. And notice I'm using parentheses. Okay, so that is the square root of 9 plus 4, which is the square root of 13. So that's my first length right there. Okay, my second length is going to be BC. So I'll leave B being my second one. I'll make this my first. Okay, so my y2 is 1. Excuse me. Let me start with my x's. My x2 is 5. My x1 is 0. My y2 is 1. My y1 is 2. So that gives me the square root of 5 squared plus -1 squared. When I simplify that, that gives me the square root of 26. Okay. Now I'm going to move on to my next length, which is AC. So I'll go ahead and make C my second one now. So for AC, and I'll block these off so we know where they stop. For AC, we've got the square root of so my x2 is 2, my x1 is 0, my y2 is -1, my y1 is 2. Okay, so when I simplify that, I'm going to get 2 squared plus -3 squared. Notice how I'm using parentheses the whole time, guys. When I simplify this, I'm going to get the square root of 13. So I already know this is going to be an isosceles. Ooh, how do I spell that? I think I spelled it right. Isosceles. Now, because it's not an equilateral, I also need to check the lengths of the sides to see if any of them are perpendicular. Okay? So I'm going to find the slope of AB. So that would be, I'll make A my first and B my second. So y2 minus y1 divided by x2 minus x1. That gives me -2 over -3. When you have a negative divided by a negative, that just becomes positive. So I know the slope of AB is 2/3. Now I need to find the slope of BC, or CB. I'll make B my second one now. So y2 minus y1, x2 minus x1. That gives me -1/5. So far none of them are perpendicular. Now I need to do the last one. For AC, I'll make C my 2. So y2 is -1, y1 is 2, x2 is 2, x1 is 0. So I end up getting -3/2. Okay, so actually we do have a set of parallel lines. AC is parallel to AB right here, because not only are they reciprocals, but they're opposite signs. This one's simplified to be positive, and this one is negative. So this is isosceles right triangle. Isosceles right triangle. Not only does it have two congruent lines, but it also has a right triangle. So this is what we would call an isosceles right.